Welcome to this episode of the Aquarist's Edge, a podcast for home aquarists just like you. Learn more about how to keep a thriving aquarium and discover ideas and tips to give your aquarium the edge. And now, over to our host, Arthur Preston.
It's often been said that fish keeping is more about keeping water than about keeping fish. Is this true? Do we as aquarists need to spend a lot more time sorting out our water quality, figuring out the parameters of our water? Perhaps so, if we are to keep our fish and our aquatic environment at peak condition. So then, what exactly is water chemistry? We hear people talk about things like pH and GH and KH, and for some of us initially, that's a little overwhelming. So in today's episode, I'm going to take you through the basics of understanding water chemistry. This podcast episode is not aimed at the advanced aquarist. This is for those of you who are starting out in the aquarium hobby. Perhaps you're a little bit more advanced, but you really haven't mastered the idea of water chemistry yet. What are all these abbreviations? What do they mean? How does it impact our fish? Why should we care? So let's get into it. So what actually then is water chemistry? Well, at its core, water chemistry refers to the chemical properties of the water in your aquarium. And unlike pure H2O, aquarium water contains dissolved minerals, salts, organic waste, and gases that can influence its quality. And it's these factors collectively that determine whether your tank provides a healthy environment for your fish and your plants. So, what are these parameters? Well, let's start with one we often hear spoken about, and that is pH. That stands for potential hydrogen. The pH measures how acidic or alkaline your water is on a scale from 0 to 14. If your pH is less than 7, it's regarded as acidic. A neutral pH is 7, and anything above 7 is considered alkaline. And the pH affects many biological and chemical processes in your tank. For instance, ammonia, which is toxic to fish, becomes less harmful ammonium in acidic water due to a shift in chemical equilibrium. Now, what this means practically is that fish in acidic environments are less prone to ammonia poisoning compared to those in alkaline conditions. For the majority of freshwater tropical fish, a pH range of 6.5 to 7.5 is absolutely fine. There are some species that require a different pH. For example, your African cichlids are far more comfortable in a range of about 7.8 to 8.6. So how then do you go about adjusting your pH? Well, to raise your pH, you're going to use crushed coral, limestone, or a commercial alkaline buffer. To lower the pH, you're going to add driftwood or peat moss or natural acids like diluted citric acid or diluted vinegar. But what about the nitrogen cycle we hear so much about? Well, that really speaks to ammonia, nitrite, and nitrates. And these compounds form part of that nitrogen cycle, which is vital for breaking down waste in your tank. Fish waste, uneaten food, and decaying plants release ammonia. Beneficial bacteria convert the ammonia into nitrite, which is also toxic. But there's another bacterial group that convert nitrite into nitrate, which is less harmful, but should still be kept below 20 parts per million in freshwater tanks. High ammonia or nitrite levels can cause severe stress, gill damage, and even death. So how do you manage this? Well, first and foremost, cycle your tank before adding fish to establish beneficial bacteria colonies. Now, there are people who say you can do a fish in cycle. I have done that. You use a simple fisher, you keep very low stock, maybe one or two guppies. They obviously produce waste. That kind of kickstarts the bacteria in your tank. You can also add commercially available bacteria that you just add into your tank as you start it. But even so, I would still leave it for several days before introducing the majority of the fish. And at any rate, it's always a good idea to introduce fish slowly into your aquarium. You could also perform regular partial water changes of about 10 to 20% weekly to dilute the nitrates. And importantly, avoid overfeeding and make sure you remove decaying organic matter promptly. What about this GH thing? What is that? Well, GH is general hardness, and it measures the concentration of calcium and magnesium ions in the water. Soft water is less than 4 degrees of general hardness, and hard water is greater than 12 degrees of general hardness. Now, fish from soft water habitats such as tetras and discus, they may struggle in hard water due to mineral imbalances that affect the process of maintaining internal salt levels. The fancy word for that is osmoregulation. On the other hand, hard water species such as African cichlids thrive in mineral-rich environments. So how do you go about adjusting the GH? To increase it, you would add crushed coral or commercial remineralizers designed for aquariums. And to decrease it, you can mix reverse osmosis water or RO water with tap water. The other H, if you like, is KH. Now that measures the buffering capacity of your water. It's called carbonate hardness. Basically, it's the ability of the water to resist changes in its pH. A low KH is less than 4 degrees of carbonate hardness, and that means that your water is very prone to swings in the pH. Whereas a high KH, which is greater than 12 degrees of carbonate hardness, means your water is stable, but it may make lowering your pH difficult. So how do you go about adjusting it? To raise KH, you would add sodium bicarbonate or baking soda at a rate of about 1 teaspoon per 50 liters of water. To lower the KH, you would use RO water or add natural acids such as driftwood or peat moss. Dissolved oxygen levels, or DO, are critical for fish respiration and the activity of your beneficial bacteria, and a low DO can lead to stress and poor biological filtration. You also want to make sure that your carbon dioxide balance is right. High CO2 levels lower the pH by forming carbonic acid, but they're also essential for plant growth. So use an air pump or surface agitation to maintain adequate oxygen. And tailoring your tank's chemistry to the natural habitat of your species ensures their health and encourages natural behaviors. Most of the tetras, for example, prefer soft water with a low GH and KH and a pH of between 6 and 7. Whereas, as mentioned earlier, your discus fish, they require stable conditions with a pH of 6 to 6.5 and warm temperatures of about 28 degrees Celsius. I mentioned African cichlids earlier, they prefer hard alkaline water. But what about live bearers, the very popular guppies and mollies, for example? They adapt well to higher GH and KH levels and a pH of about 7 to 8. Now, what about the species that require brackish water? These are fish such as your bumblebee, gobies, and figure-8 puffers. Well, they need slightly salty conditions with a pH of 7.5 to 8.5. So on a very practical level, it's always important to research the natural habitat of your chosen species before setting up your tank. If you want to have a species-specific tank, it's obviously much easier then to tailor your water chemistry to that particular fish. If you have a general community aquarium, aim for a general pH of around 6.5 to 7.5, and that should be okay for the vast majority of your fish in a community tank. Even small changes in water chemistry can have profound effects on your aquarium's inhabitants. Fluctuations in pH or ammonia spikes weaken the fish's immune systems. Fish may gasp at the surface if oxygen levels are low, or exhibit erratic swimming if they are being poisoned by high levels of ammonia. Many species require specific parameters for spawning. For example, discus needs soft, acidic water for egg fertilization. Maintaining stable parameters will ensure that your aquatic life in your tank retains its vibrant colors, the natural behaviors, and have long-term health. This may all seem somewhat overwhelming, and I understand that. So go on and get yourself a basic water test kit, test the water on a regular basis, see how you go. It's a bit like figuring out the secret formula for your aquariums. It's not impossible, it can be done, and you will be very grateful that you've taken the time to do so as your fish begin to thrive even more than they currently do in your aquariums. Understand the key parameters, your pH, ammonia, nitrite, nitrate levels. Understand GH and KH, and try and make sure that your tank meets the needs of the fish that you have in it. Consistency will be key. Regular testing and small adjustments are going to be far better than drastic changes that can shock your tank's inhabitants. Regular testing and small adjustments are far better than drastic changes that can shock your tank's inhabitants. Take it slow, make small changes, and over time, you will find that your aquarium begins to thrive. Your animals, your fish, your shrimp, your snails, your plants are going to be that much healthier. And you'll be grateful that you've invested the time and the energy in sorting out your water parameters. That's it for this episode. Thank you for tuning in. I look forward to being with you in the next episode. Please like and subscribe this video if you're watching on YouTube. If you're listening on your favorite podcast app, please follow us. Please make sure that you leave a review if you're able to on Apple Podcasts or other podcast platforms. I would really value that. And thank you for your time. So keep learning, keep curious, keep having fun in this amazing hobby. I will see you all on the next episode. Take care for now. Bye.
That's it for this episode of the Aquarius Sedge. Please consider subscribing to this podcast so that you don't miss further episodes. We would love it if you would also rate and review the podcast, as this helps make it visible to others. Until next time, keep learning and discovering, and keep finding your Aquarius Sedge in this captivating and fascinating hobby.